Okay, so good morning again, everyone. I think we are going to start because it's 9:01. So let's start. I'm Sophie Dolans-Caranta, working for R2M Solutions France. I'm very glad to chair this paper session. We are going to have 4 interesting presentations. The speakers will come here at the desk and will use the mic, okay, because we also have people online. In case there are some questions from them, by the way, I will, of course, moderate these questions. So let me introduce the 4 papers and speakers we're going to have today. So we have Branca Delmonte, representing also Stefan, Maas, from the University of Luxembourg, and the paper is The Impact of Optimized Set Values in Secondary School Buildings. Then we have Juan Carlos Guerrero Ramos from AIDIMME Technological Institute, and he will talk about circular economy-based materials development to foster the transition to sustainable and high energy performance buildings at optimal costs. Then Sultan Cetin, representing also Henk, Visscher, and Hwang from the Delft University of Technology, will present data collection techniques and technologies for digital building logbooks, 3 logbooks and a case study. And finally, Merve Mermertaş, representing also Beril Alpagut from Demir Enerji, will present district energy concept evolution from positive energy district to positive clean energy district. What are the main considerations from annual surplus energy to climate neutrality? So if we have, each speaker has 20 minutes for the presentation. Of course, if there are some questions, we'll try to take them on the spot, if you agree, if we have enough time. And in case there are additional questions at the end, I will be very happy to take them if we have enough time. And we'll go for the coffee break at 10:30. Okay? So let's start the first presentation. Branca? Okay. Sure. And I will put this in a full screen. How can I do this here?
This microphone is working?
I think so. Let's try it.
Stand, maybe?
Of course, if you're more comfortable. Yeah. No, but in fact, you may not be seen by the online audience.
Now? Yeah, now.
Oh, yes, you will.
Yeah?
No, you're seen because there's a...
Okay. I promise to stay close.
Okay, so I'm switching off this one. Okay. So it's 9:05, so you have 20 minutes.
Okay, thank you.
Thank you.
Thank you. Well, hello everyone. As you heard, I'm Branca Delmonte from University of Luxembourg, and I'm happy to share with you today our study on optimized operation of educational buildings, which is a way to address the challenge of reducing energy consumption with easy to implement measures without big renovations, while keeping comfort levels for users. The idea is to find solutions that can be implemented today and to contribute to reducing the energy consumption and related carbon emissions in school buildings. This was developed within the Energy project. It's a concept developed during this project, and that I'm still working on. The choice to work with school buildings are mainly due to the important emissions from the building sector, but also from the important building stock of educational buildings, older buildings. And of course, the great outreach and dissemination capacities of these buildings, which we are looking actually to work closely with students, citizens of the future, so that this can be replicated outside of the school environment. Our approach is based on this 5-step methodology for schools to become more energy resilient. It starts actually by understanding the environment, which means knowing the different stakeholders. I don't know how is it in your countries, but we are working in Luxembourg and we have so many stakeholders in one educational building with very different interests, with their very different approaches with regards to the building. So that's the first step, understanding who are these stakeholders, what they know about energy efficiency, what are their interests on working on that, what kind of resources they have, what kind of activity they already do. And then to group these stakeholders in one working group, or as we called, a learning community, so that we can profit from experiential learning using the school as a living lab. Then, in a second step, we propose to use education to actually engage with the community. There is very focused on the students, of course, the main users of the buildings, but of course including staff, teachers, and everyone that is related somehow to the way that the building is operated. The idea is to find matching activities with the curricula, such as studying heating systems or thermal losses in physics, or proposing some energy week and workshops outside of the curricula, so we can use the lighter approach to get them engaging with the energy efficiency subject. And what we are looking for, aiming for, in our goal on reducing the energy consumption, is actually having the school community involved in the process, so we can actually get to understand really how, or which are the needs, the energy needs of the building. Then we come to a more technical step. The third step is an energy audit. And as I said, we want to include the students in this process. So actually, we want to include not only students, but the staff and the teachers on understanding the building, the physics of the building, so the envelope, the structures, the technical installations, but most of all, understanding how these are used. So which parts of the building are used, when, why, and what can we change actually, what are their ideas or how they see that the building could be used in a different way. In this step, we will collect a lot of information to, as I said, match or to understand the way energy is consumed in the building in the easiest way as possible, so that the students can actually understand that it's not a very complicated process. It's basically analyzing your consumption and comparing with references. And the approach we use, as I said, we are working with Luxembourgish educational buildings. We have chosen 4 pilots. They are all big buildings built before any energy efficiency regulations, although they have been refurbished over the years. So we start the analysis of the energy consumption by collecting energy bills information. So just to have an idea of the overall consumption over the year, and by dividing by the gross floor area, we can have the specific consumption of each building, which we can then compare to local references. The bars here are representing 25 educational buildings in Luxembourg older buildings, and the dark blue are our 4 pilots, where we can see that actually on the thermal consumption, our buildings are not behaving that bad. They are all below the average, the national average. When we are talking about looking for solutions to reduce consumption without big changes in the building, finding solutions in this area would be more complicated because they are already behaving in a good way. However, when we look to the electricity consumption, we can see that our buildings are all either at the average or above it, and that's why we then focus our analysis for the 4 buildings on the electricity consumption. And then we do with the students a further analysis of the energy consumption or the electricity consumption, such as analyzing energy or electricity consumption patterns. Here we have a graph. I'm sorry if it's a bit too small, but here we have a graph with every weekday, and each color is representing a different period in the year. So we compared 2 holiday weeks and 2 normal weeks in winter and summer, and we have the weekdays and the weekends, where from that we can see the influence of the users on the energy, on the electricity consumption, and we can see the influence of the climate or the meteorological conditions. Furthermore, we can see from August, for example, when the schools are completely closed, and we can confirm by checking the weekend consumptions, the base load consumption of the building, which is the energy that is being consumed even when the school is closed. There is no one using the building, and we still have a quite impressive consumption happening. And when we are talking about finding ways to reduce the consumption without doing big changes and keeping comfort, there is a great opportunity to working on these base load consumptions, right? Because then there is no influence on the user. Another analysis that we propose is to identify the different users, so the big users. So to find, we install smaller electric meters to identify more the distribution of the electricity consumption, where here, for example, we can see that for this building, both lighting has a very important part of the consumption, is responsible for a big part of the consumption, but the sports hall and the swimming pool are responsible for more than 30% of the total energy consumption of the building. And then we can start thinking about a strategy to reduce the consumption. Discussing again with the community and trying to find solutions that would be adapted to their requirements and that could provide great impact. So as I said, we focus a lot on acting on the baseload consumption, and we propose these reduced operational modes for these periods. When the building is not being used, we don't need to heat as much. I know it sounds very obvious, although it's not. And that's why we need a good monitoring plan, because people think they know how the building is being. But when you start analyzing the data, the consumption data, you see that actually they thought the things were off. They thought that the equipment were not running. We need a follow-up. We need people following the way it's being consumed, and then adopt the proper operational set points. And then we come to the final step, which is actually checking what was done or implementing what was done or what was proposed, checking the results, and then going back and reviewing the intervention plan. Here I have an example from the lighting system. Of course, again, we are talking about older buildings which means that we have older lighting devices. You could say, oh, but it's much easier to just replace all of them. But doing that requires funding or resources, and also sometimes we are just disposing things that can still be used. So what we propose is to start today operating in a more efficient way. Here what they did, it's simply guaranteeing that the hallways of the schools just met the minimal requirements, meaning you have enough light to walk through the hallways, but you don't need to have extra light for that. And with that, they managed to save 5% of the overall consumption, which is impressive for educational building. I'm sorry about that, the text doesn't match. That is related to the swimming pool. And here, again, by adopting a reduced operational mode just during holiday weeks over the year, not summer, holidays just over the year, we can save around 8 megawatt hours by reducing the pumping time and the ventilation time when the facilities are not being used. And then finally, by emptying it, the swimming pool during summer holidays, this represents 9% less consumption over the year. Then, as I said, the idea is to evaluate what was done and then go back and see what else we could do. As I said, our first focus was not on the thermal side, although, of course, these are older buildings and we can propose some other solutions. And then this is where we started checking, for example, for improving the windows to reduce the losses, to adopting very easy controls on the ventilation system that would run only when it's necessary, avoiding also when we leave the room, because lighting is also an easy thing to just turn off when we leave the room, but ventilation, no one thinks about it, it's just running. Having small or very thin insulation from the inside behind radiator niches, for example, and giving control to the user. This is a very discussed solution, but has a great impact on getting people to feel comfortable because they know that they can control the temperature that they have when they're using the building. Of course, it comes with education because then they need to understand as well that when they leave, they have to reduce it. As I said, we have a very complex stakeholder chain and we have many different objectives, and that's why we are working closely with the psychology department to help us to unlock this chain and to go further, because what you can see from the methodology is that the technical part is actually very, very small. The hardest part is to get people engaged and working with us. In conclusion, as I said, our goal is simply to match needs and consumption. And for that, we need monitoring, we need people involved, and we believe that the educational approach is the best way to reach better performances in and outside the school environment. Thank you very much.
Maybe keep the mic in case there are some questions. Is there any question? Just a small one. What type of schools have you targeted, like primary schools, secondary school?
Sorry, secondary, but we are also working with the university building, so upper, older students. That's why they can play a more important role on the changes. It's true that we also believe that it's good to start from the little ones, but then it's a more informative step, and then from 12 they are already capable of giving feedback, of giving inputs, and that's what we are working on.
Okay, thank you.
Thank you.
I see a question here. Maybe if you can use the mic, because this way people online also will hear you.
Very small follow-up question, actually. Out of, I think, 26 schools you analyzed, are there any smart schools in terms of smart buildings, the smart devices in there where you can control climate, etc.?
So smart schools, they are very old buildings, right? All the 25, they are older buildings in the country. Of course, many of them have different smart devices. And then it's where we get to another conflicting point, because we have these devices, but they don't work properly. Because of the older installations, it just doesn't match you just don't reach what you are looking for. For example, we had smart valves for the heating system, but it could not work with the older distribution. Or you have controlling systems for the electricity, and actually the electrical cabinets, they are so how can I say, not updated, that no one really knows exactly what is leaving that cabinet. So this was a big part of the energy audit, was actually understanding what was feeding what, and this distribution of the consumption is very complicated, especially in older buildings. I don't know if is that okay? No? Thank you very much.
Thank you very much. So we can move to the next speaker. Juan, do you prefer to stand or to sit?
Okay, maybe hybrid.
Okay.
In some parts I'm gonna go into the
Okay.
front. I just have to push some button.
This, I don't know.
It's
Yeah.
okay, if not, I'm doing
Yeah.
it here.
Okay.
Yeah. Thank you.
Thank you.
Okay. Hi everyone, thank you for being here. I'm glad to be here at Sustainable Places. I'm Juan Carlos Guerrero from AIDIMME, a technological institute in Valencia, Spain. We are the managers of this project, SNOC project, and also we have a technical park in some work packages. And I'm gonna talk about the advance we have until now about this project. We are in the month 10, so it's a little bit early to have so many results about the development, but there are some that will be interesting to see. My presentation is named Circular Economy-Based Materials Development to Foster the Transition to Sustainable and High Energy Performance Buildings at Optimal Costs. So, our SNOG philosophy is to be a European project that aspires to contribute to a world where buildings seamlessly integrate with the environment by reshaping the construction industry and fostering the transition to zero-energy buildings. As I told you, the project started at November 2023, and it's 42 months long, the project. These are our partners of the consortium. There are technological institutes, universities, technology developers, also construction companies, industrialization companies, etc., and material developers also. The order of the presentation will be the SNOG project objectives, ambition, and methodology. After that, we are going to talk about the analysis and design optimization of the bio-based materials, that it's the material that we at AIDIMME are developing. there are 4 solutions. I'm going to talk about it after. So our ambition in this project, as you know, in order to stimulate Europe building rehabilitation, the European Union has introduced many ambition policies, like is the zero emission buildings for 2050, a renovation wave strategy for all their buildings, and a circular economy plan, which wants to promote designing products and infrastructure for longer lifetime, reusing and recycling raw materials. The assess buildings energy emissions from a life cycle perspective. It's also in the embodied energy and the operational part of the manufacture. We want to implement energy efficiency measures during the design phase, which minimize the low carbon, to have low carbon materials, monitor and test materials in a real environment, and standardization for new materials that are not so very clear in some cases or in some countries, etc. Well, the objectives is, how I said, a good strategy to refurbish or design these zero-emission buildings is to act on the envelope or retrofit of the buildings. So that's the main part where we are developing our solutions. The installation of insulation materials proved to be very effective in the reduction of energy consumption in buildings. In general, the project is not, we're going to develop a digital tool assistant based on AI and virtual simulation. This digital tool assistant will help, for example, architects, engineers, constructors to take decisions depending on the geography and the climatology where the building is going to be refurbished. Helped with a database of thermal insulation materials, including metrics and LCA information. Also, as I told you, we're going to set a sustainable by design thermal insulation materials, 4 of them in total, and a digital building logbook. Maximize the energy efficiency and minimize the greenhouse gases emissions through the cycle. Well, as you know, I'm going to explain it a little bit, this is like the LCA procedure, the life cycle stages, sorry. First is the production, where you take the raw materials, then the transportation of those raw materials to the manufacture place and the manufacture itself. Then you have the construction part, the transport, the construction, and installation processing. And in the use, you have also embodied energy, embodied factors, and operational factors that are like the use of energy, water, and so on. And in the use embodied is the use, the maintenance, the repair, the replacement, and refurbishment. End of life is the demolition, transport, the processing of the waste, the construction, the demolition waste, and the disposal of those materials. I don't know if it seems good in the screen, this part, okay.
It's a bit small.
Yeah, okay. So I'm just gonna name the 4 solutions we're gonna develop. It's our specific object in the project, our first specific object. It's the first solution is gonna be an aerate sustainable concrete. The raw materials from which we start this development is the biomass ash is from rice husk and recycled diatomates from beer and wine. We will develop products as blended Portland cement, blended cement with diatomites, geopolymers, and self-leveling mortars. The second one is going to be a sustainable mortar with smart additions from heated floors. There are 3 companies that have been developing this technology, and the application is a self-leveling mortar for floors. Then the aerogel process from wastes. This is made out from construction and demolition waste and stucco mortar. Stucco mortar is like the mortar you put in the walls to make like the end composition, well, the end view of a wall. And the other one that it's gonna go more deeper because it's our developing AIDIMME is the biomass-based boards agglomerated with bioadhesives. We started studying many biomasses like rice husk, hemp, posidonia, sunflower. And the bioadhesives are, those are made for another company called Chimar from Greece. They're experts in this part, and they're made out of tannins, lignin, and starch. What we want to develop is an ethic system for outer insulation, and also and also could be used for an indoor insulation. The second specific object is to industrialize these products. Now you can see some pictures about the industrialization that we made in another national project. So this is like a background about what we're gonna do now. We went to an industrialization company, and they prepared some molds. Then they prepared like the mixture of this is with Posidonia specifically. Posidonia oceanica is a sea plant that it's protected because it's one of the most oxygen apporters, I don't know how to say it, in the sea. And this Posidonia is taken out from the coast, from the seaside, from the coast. And many of the times they just burn it, and there's nothing to do with this material. So we take it, we dry it in some like big dryers, just at the sun, no energy used for this. And we mix it with the adhesive we're gonna use. And then with hot press plates, we make these panels that you can see in the number 5 image. Okay. I don't know if it's okay. Also, as I told you, we are gonna make this digital tool assistant. The purpose of this tool is to select the best thermal insulation solution and installations depending on the geography and climatology. Our developments are gonna be demonstrated in 3 different countries, 3 different buildings. The first one is in Switzerland. It's a residential house. The second one is in Spain, in Castellón, nearby Valencia. There are offices and also like a manufacturer building. And the other one is in Norway. It's a new residence building. We just have like the model by now, and they're ending the construction of it. As a background, we have done in a national project there in Spain, in Valencia, we put these panels. These ones are made out of rice husk. If you can I stand up with the micro? Or sorry? Can I stand up with the micro so I can? You can hear me? Yes. Okay, so this is the core. This is made of rice husk, and the outer layer is made out of mortar, where it's 60% of the sand is from recycled of the construction and demolition, from construction and demolition waste. So we put some thermal sensors in each of the layers. It was initial existing wall, so we put also in the layers of the wall, And with it we monitorize the changes of temperature and compare it here without our material and here with our material, that they are like twin facades. This is our mechanical profiles where we put the panels. Now we want to use less aluminum because of the embodied energy that it assimilates, and just use it or change material maybe if the time helps, and just use it in the connection parts. So this is like it looks after with our solution. Without our solution, we put a meteorology system to take temperatures, outer, inner, the rooms, and also all the temperature sensors that are in each layer. Okay. Well, as I already told you, we have the background. It doesn't sound weird with the two. Okay. Also, we have developed this one with the wood. It's for separating rooms. They are for inside insulation. And the other one is for outer or also inner spaces. You can use it here, and it's like the similar finish of the ones that you can see around. Okay, our KPIs will involve circularity, the percentage volume of end project you can reuse of the materials, the embodied energy, CO2 emissions, and counting on biopanels and also the sandwich panels. We name sandwich panels when you have the mortar layer also. Also thermal conductivity, dimensions, reaction to fire, that it's important, and volatile organic compounds. These are the values we want to afford with the project. And for now, we have tried many combinations of materials. We have used hemp, rice husk, sunflower, citrus waste, and Posidonia. It's also nice to say that we are using biomass wasted that are local wasted. There are lots of it in, for example, the Comunidad Valenciana, or hemp or biomass that you can find easily anywhere. So it's easy to industrialize these products. Posidonia is a Mediterranean sea plant. Citrus waste in Mediterranean geographies, countries where you can find it. Sunflower also, and also rice husk is everywhere. Okay, so at the end we decide, because, okay, I'm gonna talk about these values. We decide to use hemp. You can see it's not with the best numbers or best properties, but mechanical, the internal bond, the last column, is the best material that we are studying. So it was a very a property that has so much value for us. And also in the acoustic insulation, it's nearby the sunflower, as it has the same value, 20 decibels, 21 decibels of absorption. The reaction to fire, even though the numbers are a little bit far one from another, they are all category C in an euro-based normative. And the thermal conductivity is not the best, but is into the values that it works as an insulation material. So we decided to use hemp fibers and a tannin-based resin that is a phenyl formaldehyde with a 40% of substitution of tannins. And there's also still work to do because we're starting the project. And in AIDIMME, we're gonna study all these properties: moisture content, ash content, sand content, fungi resistance, specific heat, compression resistance, so another mechanical properties, stability, and water absorption. And also we have to replicate the first trials, as you can see in the last, to the right picture. There are all the different combinations. So we have to take a decision about the density, about combinations, the quantity of adhesive we are going to use, etc. So there's still work to do and values to take out about this project. And well, thank you very much. And if there are questions, happy to answer.
Is there any question in the room? Yeah.
Thanks for the nice presentation. I was just halfway seeing, so I didn't get it. Maybe just one short question. You said that you want to replace the aluminum and for installation of the panels. So you have this aluminum now to install.
Yes.
Yeah. You say you're going to replace that aluminum by which method or by which how to install in the future this? Because are you going to use nails to fix?
We use nails to fix it to the existing wall. And now we're using aluminum, but if we have time in this project, we're gonna, this is the point that we have to improve the best because of the embodied energy that these materials have. It was the solution in this moment in the other project we have to take, but it's the point we have to put more attention now to find a better solution, more sustainable, that mechanical properties go well on it. So
yeah, that's another comment. If you plan to use nails, then it probably cost the summer bridges more on that.
Yeah, exactly.
So that's something probably you can also work on in the future.
Exactly. We make this with this camera, thermal camera, as a study, and there's the thermal bridges are just in this part. So okay. There's always room to improve the projects, and this is one that we are very focused on. Mm-hmm.
Thank you. Yes, another question?
I had a question about your pilot demonstrations. Will you be applying it in like parts of the building where you can control the other aspects? I don't know, maybe heating or ventilations that could change or could affect, could be affected by the new installation, or are you looking at a more global replacement of all installations in the buildings? So is it like selected parts of the buildings or completely?
For demonstrating or yeah, for an end use?
Demonstrating. I think there was 3 pilot cases, right?
Yes.
Yeah, yeah.
This, like this one, no?
Yeah.
Okay. This one is just to study 2 different rooms. Okay. So we have, we can analyze in every layer. When I say every layer, is the mortar layer, the rice husk, insulation, and also the insulation that was existing in that building before. So we compared the temperatures inside. At the end, the users is the one that rules. And we have been, we had like 1 point, I didn't put the graphics, there's a graphic about the difference between them. And it was like 1.5 degrees less in, excuse me, more in winter. We are now analyzing the data from last summer and see how it works in that conditions. So at least in winter we have gained 1.5 degrees that it's more comfortable for the end users. So it's working, and we have to make some more evaluations, and also we are gonna monitorize the new demos. And the new demos will also have a moisture content analysis and monitorization. So also is another thing to take account.
one very last question, and then we move to the next speaker.
Yeah, I don't know which.
Very short one, thank you. What about the thermal capacity, specific thermal capacity?
The smoke?
Specific heat capacity. So, do you have some data about?
Now we haven't. This is one of the tests we have to still have to do.
Okay, because that would be an interesting also parameter to see how they have contribution to probably to the demand response. Then, so if you have a heavy, or a large specific heat capacity, or okay, yeah, but yeah, I would.
Okay. Mm-hmm. Yes, it's something we have to still measure.
Thanks again for answering the questions.
Thank you.
And we can move to the next presentation. So I'm giving the floor to Sultan Cetin, representing the Demobilog project. Sultan, do you want to sit?
I don't know yet.
Okay.
But I think I'll start standing, and then perhaps I'll sit.
Okay.
Just let me sit.
So you can use this mic. I'm switching off this one.
Yes.
And you have 20 minutes.
Thank you so much. Hello, everyone. My name is Sultan Cetin. I am a postdoc researcher at the Delft University of Technology, and today I'm gonna present a small research project we're doing as part of Demobilog project, together with Sana over there, Hwang, and Professor Henk Visscher. As you can see, the title is Data Collection Technologies for Digital Building Logbooks. But before actually starting my presentation, I would like to ask you whether you're familiar with the term digital logbook. Okay. Yeah, I also saw in your presentation. Yeah. Yeah. Also for us, we are doing research. For us also, it's a little bit vague. But I was curious if you have heard of it, because we will be talking about it in this presentation. So actually, I want to pass the microphone to Suna, because she uses a really good analogy when she explains digital building logbooks. I really like her definition.
Essentially, what it is like a health card for humans. So from the moment you're born until the moment you've passed on, every data about your insurance, your every prescriptions that's been given to you, every vaccination that you've been taking, every illness that you've been gone through, it is stored digitally somewhere. And depending on the country, whether it's centralized by the government or by the specific insurance companies, that depends. But essentially what a DBL is to a building is the health card for humans. Yeah, that is.
That's a really good description, and what you see, if you want to read it, please go read it. I'm not going to read this, but the European Commission has released a series of reports, and they made a really large definition of what digital logbook is. Well, actually, it helps us to monitor our buildings and then put all the data related to our buildings, and also help us to deliver sustainable interventions from energy transitions to circularity. So this concept is actually has been mentioned in several policy documents. Suna is working on a paper at the moment, analyzing all kind of data and also policy about digital logbooks, and we will be publishing about this. I just wanted to mention, if you're interested, there will be a research coming up. A little bit about Demobilog. At Demobilog, we're not actually developing new DBLs, digital logbooks, but we are working with 5 partners who have a connection with around 4.5 million homes, which is quite a lot. And they are we are trying to develop new functionalities to improve their products, from user-centric automated renovation advice to multi-cycle circularity applications. So here are the 5 partners. They are from 5 different countries. Pass from Belgium, Sirdax from the Netherlands, Clea from France, Capsa from Germany, and Chimney from the UK. And today we'll be focusing on 3 of them. Well, a little bit about the context of our research, why we wanted to do this research. Data is fundamental for sustainability interventions, for renovation and circularity, for example. In my opinion, actually, we operate in a really data-rich environment, but there are structural holes in the entire life cycle of buildings. From, for example, architects start with really nice Revit models, but after 30 years, no one knows where the models are when you really need them. So we don't really have this full life cycle data model of our buildings. And for example, when we renovate our buildings, we need accessible and reliable data. And DBLs actually can help us to access those data. But what we notice in our buildings with DBLs, with different partners, that they offer different solutions and they require different types of data. And this creates another layer of problem. And then we said, here actually in another context that I use a lot in my papers, how I see data actually. So in the data collection layer, we gather data from various sources. So it could be like paper drawings or BIM model, although it's a technology in itself, or databases. And then through data integration technologies, we try to understand and curate that data where they belong to. And at the end, we try to make sense of the data, and then we try to get insights at the top of the layer. So how we see DBLs is kind of in between at the data integration layer. So they really help us how we should collect data and then turn them into valuable insights. Here today, in our small research, I'll be focusing on data requirements and indicators, actually, with our partners. So our aim was, as I mentioned, there are different types of DBLs. So how different types of DBLs collect data. We wanted to observe from a real case, and how can we help them through the advanced digital innovations. And this is also connected to a work package, actually. Not only our research, but this research benefits our project as well. So we are conducting a multiple case study. So we have 3 cases. What you see is Dreamhuis. This is a replica of a digital, typical Dutch house in our campus in the Green Village. So we used that as a case, and we invited our partners to collect data for their own DBLs. Sirdax and Capsa came to the Netherlands and collected data from the physical building, and Pass collected data through online because they operate like that. This is an ongoing research, so unfortunately I don't have the full results, but I'll try to give some insights. So once we are done, we will do a cross-case analysis to highlight the differences and similarities, and we aim to come up with some recommendations. So a quick overview of the cases. Pass really focuses on energy transition and try to give the residents in the Flanders free advice to renovate their homes. It's totally public, so users, everyone who own a house in the Flanders. And Steerdax really focuses on reuse and recycle of the building materials, and also they give insights into carbon reduction. They are a private company, and their target users are designers, demolition companies, or project contractors. So because it's about reuse and recycle, they focus more on the end of life cases, but they collect, of course, during the operational stage. And finally, CAPSA is also focusing on energy transition. It's a private company, and they work mainly with social housing organizations. So let's take a look at how these platforms look like. This is Woningpass. So they have different modules, actually. It's kind of, yeah, your digital ID. I don't know, in the Netherlands we have our own DigiD. Probably in different countries there are different digital passports for everyone. This is for your building. So you can find actually all kind of data about your building, and you don't have to input anything. It's just created for you. You don't have to pay. The government gives you this option. This is super cool, in my opinion. What they do, actually, in energy module is to also, you need to have an EPC label. If you don't have, I think, if I'm not wrong, Suna, they also roughly calculate it for you, right? So depending on the energy level, they advise you on what kind of interventions you can make to improve the energy label of your building, and then they provide here some kind of costs. And for example, if you want to improve your windows or roof, and what would how much would it cost, etc. What they want to do in the coming years is these costs are quite fixed. They want to make it a little bit dynamic and to the real price. So we are still working with them because they need an expert to send to site, and it was a little bit complex to do it, arranged in the Netherlands. We provided with a lot of information, drawings, etc. We will see how the expert can calculate EPC for us, and then we will have more insights about it. The second one is Steerdax. Steerdax is really focusing on inventorizing the building materials. So as you can see, they created here the Dreamhouse profile. Are there anyone working on circular economy? You a little bit, but anyone else? Are you familiar with shearing layers? So in the buildings we have different layers like site, structure, skin as the facade, services, space plan and stuff. So they use this structure to collect data. I just clicked on, I think, skin, meaning the facade. So here you see all the walls. And then they actually enter their really basic features of the outer walls. How they collected data, let's take a look at it. So indicators, sorry, I missed that part. By collecting all that data, they actually give insights into your building. So how much percentage reuse potential or downcycle or recycle in the entire building. Also, they separated into different materials as well. And they are now working on the cost and CO2 calculations as well. So, so when they came to the Netherlands to collect data from Dreamhouse, they basically walk around, make measurements, and they have an iPad, as you can see here. So with drop-down menus, for example, when they see a door, there's an option for door and the material, and then they quickly measure it and input that data. They also, when create a profile for a home, they do desk research through drawings, whatever we provide in advance. After that, we did some interviews to understand what other technologies can help to improve the data collection method. For example, BIM models are really important. They can extract data, but the models should be really correct. Sometimes the thickness or the material layers are different than the real life, so then they say we spend more time fixing model than going checking the real building. So that's kind of a practical insight we get from them. And with other European projects, they are experimenting with other scanning technologies like infrared scanners, point cloud. These are also helpful, but they said you get the geometry, but you don't get material information. You have to go to site again to check. I think eventually we came to a point to the role of AI through image recognition. There are some tools out there in the market where they fly drones and make the other photos of the buildings, or they use satellite images to recognize windows and measure. These kind of tools can be really helpful, but again, I think eventually we need kind of a human technology combination of my time is running. I have to run as well. The last case is CAPSA. CAPSA is really focusing on two things. Generation of decarbonization advice for their clients, and also digitizing this whole data collection process. And this is the profile they created for Dreamhouse, and they provide this kind of energy balance with different colors referring to different elements of the building. So here a colleague from CAPSA making pictures, and also similar to Sirdax, measuring the component in the building. What is really interesting about that is they kind of use a mobile application to guide any kind of user to collect data. So you don't have to be an architect or a technical person to collect data. So they call it non-skilled person, a homeowner actually, can collect data for this tool. So in an hour, you walk through and there are questions. For example, is it a window? Yes, no. And the dimensions, is it double glazing or not? If you don't know, also they guide through. For example, I think in the new feature, you look at the facade, see the quality. Does it look good or bad? And then when you slide through the images, you can actually decide how good this is, right? Yeah, about that, but I can't really show that. There are some images really bad looking facade as well. So with that model, actually, they can create a model and give you renovation advice. In terms of other technologies, they experimented with ChatGPT to actually recognize windows and stuff, because they have thousands of pictures from their building stock. They manage. They say it's poor quality. ChatGPT failed, but what they do now is they actually use that kind of Gen AI tools to check the quality of the data collected by humans. Also, they had the similar concerns about BIM and GIS data. They are useful, but then really hard to integrate sometimes, because you have to fix the models and stuff. And they said, we need an hour to go site to collect data. We don't have to spend hours, fixing the models. So in conclusion, understanding data requirements and indicators are really important for DBLs. we have many technologies available, but it doesn't mean that they are helpful and cheap. So we need affordable solutions. And yeah, we need to do more experiment to understand how we combine human, let's say, capabilities with digital applications. So if you're familiar with any kind of data collection technology, please let me know so we can include in our research. Thank you very much. Yeah.
Thank you, Sultan. Is there any question about the Demobilog project or this particular aspect? Yeah.
Thank you very much for the interesting presentation. Ji Yang from ArcelorMittal. Hello. Sorry. Thank you very much for the interesting research. Ji Yang from ArcelorMittal, research engineer. I have a question about this reuse potential that you mentioned in one of your slides. Is this a data of reuse potential within the scope of your research that it can be implemented in the logbook? And which kind of indicators or assessment method you would consider or recommend for this reuse potential assessment?
Did you hear? Okay. They I think collect the volume of the components, like the measurements, and also they know the materials. They have a simple calculation method, I think, to give a rough indication about the reuse potential. It's not so complicated indicator that we have in academic papers, but more practical. If this answers your question.
No? So in this case, I propose we are just in time. Thank you again. And let's move to the last presentation of our paper session. So we are going now to hear about positive energy districts and positive and clean energy districts. Merve, do you prefer to sit or to stand? To stand. Okay. So you have 20 minutes in total.
Yeah, okay. I think it will be now. Thank you. Okay, hi. Hello, everyone. And great to be here also. And thank you to the before presenters. Hope that my subject will be interest to you also. Since this is at the concept stage right now, we are working on to developing the positive energy districts through the positive clean energy districts concept, and working on to define the clean concept there, what we should focus on when we are designing the districts as a more like from the environmental perspective. And the question that we are asking in our research and in our project Neutral PED is, what are the main considerations from annual surplus energy to climate neutrality? And sorry, by the way, this is Merve from Istanbul, Demir Enerji, and my background is from environmental engineering. So, I know we have talked a lot about this figure, but let's remind again why we are working on the building sector, all of us, and why we are trying to develop the strategies and finding solutions. As you know, the global building sector energy demand covers the 30%, and this includes mainly for the heating and cooling needs. And when we primarily considering the energy needs from the building construction, it covers the 4%. And the emissions, the CO2 global emissions, because of the building sector, is around 37%, and it covers 10,000 gigatons of CO2 globally. and the 10% is because of the producing building construction materials. Sorry, before going to there, so this is so obvious that the urban environment is so critical when we are working on to developing the climate strategies and trying to reach our climate change objectives. And this cannot be met without focusing on the buildings and the built environment. So that's why it is so critical to meeting the climate change objectives that we should focus on. And of course, there are many regulations locally, depend on the regions, and we have EPBD directive that is updated this year. And on the other hand, in the literature review, there are a considerable amount of definitions and the terms that are I mean, developing from nearly to low carbon zero to net zero, and you are seeing many like terms again on the right hand side, and the clean concept isn't like mentioned or promoted yet, what we should consider under clean. But the positive energy districts is the most, let's say, prompted issue, as European has the strategic technology plan that there will be 100 PEDs till 2025. So the definition on the PEDs is so defined yet. So what the positive energy district is actually the annual surplus of renewable energy that the district is producing more than they are consuming. And how they do this is providing the energy efficiency first, and of course the flexibility with the connection of the regional energy systems and storage systems. And the most defined term is that energy efficient groups of connected buildings which produce net zero greenhouse gas emissions, also actively managing an annual local surplus production of renewable energy. And of course, we are focusing mostly on energy part here, and the operational part is also the critical stage for the energy balance. What we are considering is, besides the operational energy needs and use, should we also focus on, when we are defining the clean, the whole life cycle of the districts? Because when we look at the impact ratio of the stages, the material part, environmental, the construction material production, environmental impact is covers also a huge amount of ratio from the impact perspective, and not only considering the constructional stage, we are considering the whole life cycle of the districts. And of course, this covers a really systematic approach when you are considering the districts. We have talked a lot in this session also. This covers the data management. We need to define the interactions between each processes, material inputs and outputs. But hopefully this systematic approach is letting us to calculate the ecological impacts also. I mean, because when you have this approach and the systematic, all the data inputs and outputs, the interaction between each processes, then you are able to calculate the ecological boundaries and the ecological impacts also other than the global warming potential. I think many of us are familiar with the global warming potential and the ozone depletion potential, which was actually an issue 20 years ago, but with the help of the Montreal Protocol, right now we are so like solving, and the ozone layer is going well. But when we acidification potential, for example, is the wet and dry deposition of the pollutants under the water, and this will cause the I mean a critical issue also, and when the nature neutralizing capacity will be finished, then the carbon storage potential of our water bodies will also decrease and will going bad. And eutrophication is another natural impact, and photochemical smoke formation is causing health issues really in the ground ozone level. And the fossil fuel depletion is the resources that we are using from the non-renewable and from the fossil fuel sources. So our concept is, should we consider whole life cycle and consider when we are working on the impact definition of the PEDs to the PCEDs, should we consider those impacts as I mentioned before? And this is the basic definition that we are proposing right now, but this is, as I said, progressing, and the project is in the beginning stage right now. That we will develop more ideas around this with our project partners also. And let's move from, that was the impact part. When besides the energy and carbon footprint, what should be the other impact categories when defining the clean? But we have also the critical elements when we are designing the PEDs. Those are the PEDs' critical components, and those are mainly based on the energy concept, e-mobility structure, and the urban macroform and the land usage context data. This is critical when we are considering where the solution would be more easily expanded, and even selecting the technological solution. Those are our components right now when we are working on to defining the suitable areas for possible PEDs development. So this is the other part besides the impact. We included the environmental context data from the spatial, besides the critical elements you showed before. Should we also include the environmental context, I mean urban environmental context data also, which are already available? For example, the greenhouse gas emission high zones could be determined by using the spatial data, or the carbon storage potential, waste production. Should we, when we are designing the PCEDs, should we also focus on the waste amount of waste production, and the urban heat island effect, precipitation should be focused on, since we are facing lots of floods events nowadays, noise pollution or biodiversity. They are all at the progressing stage right now, but as we know and saw that some of them are already available globally, even in the area that you live. You can reach them from the web-based data. Yes, so actually it was all from my side for today, but the question is, as I said, this is at the concept stage right now, and we are working on to develop, or should we develop, because there are many terminology is so huge, and when we are defining the even carbon neutrality to climate neutrality to PEDs to PCEDs, what should be I mean, differentiate between them, or should we, those two would be the same thing? That's what we have thought so far. I know it requires a huge research also, but we are working on it. So your ideas are also important. So thank you, and thank you for being here. Thank you, Beril, to my colleague also, who shared the PEDs, resources, all. Yes.
So is there any question?
We are on the same situation with digital product passports, logbooks, renovation. I can name it all. I mean, so that's a big problem.
Yes, the objective is so obvious, but we are sometimes getting lost during.
But what is your then initial kind of thoughts? How can we resolve this? Is it like research, like doing another kind of literature review? Okay, these are the terms, and then okay, let's decide on something, or do we need to talk with policymakers or practitioners, or all together? What do you think is the solution?
Our work packages and tests are already defined, and we have the way, we know how to move forward within the project. But we are also working on to updates, providing some little updates and some little like touches to the clean concept development. But yes, this is also another thought that that might require as a like more academical study. Yeah, please.
I would like to know then your opinion as a researcher, not part of the project. Would you think it's the way to go to add another term, or would you like to so I was wondering for your personal opinion as a researcher, because we're also struggling the same, to do you think it's the way to go to update the definition of a certain terminology, or add to the list of many terminologies, or
PEDs are so well defined right now, but PCEDs is not. And if we are talking about the PCEDs, and we have the like environmental crisis, we have so natural disasters nowadays, then this I think should be like the last point. I don't want to add more than like PCEDs plus PC blah 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 blah. But yeah, when we say clean, those are the things that came up to my mind actually. First, we should extend the environmental impact categories, and we should focus on more from the ecological point of the like urban environment.
Okay, so I think we can close our session. Many thanks again to you. Many thanks to all the speakers. In 2 minutes, I would like to take a picture with all speakers. Just to wrap up, so we had 4 different topics addressed today, but finally we see that it's very inspiring for all the speakers, I think, and all the participants. There are a lot of common aspects because school buildings, energy efficiency in school buildings can also contribute to positive energy districts, or new bio-based materials can also contribute to all this, and also taking into account circular aspects of building life cycles, etc. So I think it's super inspiring. And just to conclude on this aspect regarding all these terminologies, PED, PCEDs, well, I'm not a specialist in terminology, but I would like to mention this. You have probably seen already this famous drawing in which you see several big tsunamis. The first one is not that big, it's climate change. But another one just after that is much bigger, higher wave, it's the loss of biodiversity, etc. So it's not only about energy and climate change. I think we have to act on a more global scale. Yes. So thanks again to all speakers. And please, let's do a picture. Maybe, Suzy, you can take it. Thank you.